My name is Professor Name Not Important. Welcome to class. So you want to make a beat 'em up. Congratulations. You picked one of the hardest genres to get right. Completely opaque mechanics. I'm making a beat 'em up. It's not done, but it's close. Please take out paper and a number 2 pencil, and let's begin. So here's how I'm going to do it. I'm not going to make just a lecture. I'm not just going to talk at you, okay? But I'm going to explain concepts. I'm going to show examples of the concepts, and then maybe at the end, I'll give you some hints. Here's how you do it. Here's how you get going on this thing. Now make it. Make it like this. You want this to look like this. You can do it. I believe in you. I use the Godot engine. I'm going to try to make this not engine specific. I want you to be able to do this in anything. I want you to be able to do it without an engine. These should be concepts that you should be able to apply anywhere. I'm not going to say, go out and add the node and put a script on this thing. I'm not going to do that. I'll give you hints. I've never used Unreal. I have used Unity, but I don't remember a lot of it. But the point isn't what you use. The point is to learn the concept, try to implement it. I'll give you the pieces, the individual pieces, input buffers, collisions, knockback, hit stun. You got to know all these things, and you got to implement them, and then, put it all together at the end, and you're going to have something good. You can go out and start from scratch and know nothing, play around, and not follow any tutorials, but is that going to make you a better developer? Maybe. Maybe. But how do you learn? How do you actually learn anything, right? Somebody teaching you is going to do wonders. Like, if you don't get taught, if you are self-taught, you're going to miss a lot, and you're going to make a lot of mistakes, and you're never going to know that there were mistakes. So how do you learn? You go to school. Go to school, dude. School, a lot of people think school is useless, and let me tell you, grades are useless. Tests are useless. You know what isn't useless? Homework. Shocking. A lot of homework, though. Okay, there's 2 types of homework. There's busy work homework, and there's programming homework. This is homework where your professor has a good idea, you get a lecture, they explain it to you, they give you some reading material, and then they say, go try to make this. Okay, you're sitting here in the lesson. We'll have a test on it, sure, but you know what? You know what you really need to do? You need to go and make this program. And I'm going to run it through some tests. And your grade is based on how many of the tests it passes. That's what's going to teach you. Here's my point. Don't get caught in tutorial hell. Watch me instead, and I'll help you. I am Professor. Name not important. I'm here to help you. It's time for class. Okay, so what is an input buffer? Here's a gamepad, right? And it's got buttons. Or we have a keyboard, player input, whatever. And then you got your guy. Here's your guy. Now, the naive thing would be when the user presses, send a signal straight over here to attack. Attack. There's problems with this. So, let's say you're jumping. Or this could even be jump. This could be, or jump, like whatever. There's times when you can't attack and you can't jump. When you're in the air, you can't jump. Maybe your game you can't attack when you're jumping, but you want to press the button and you want it to happen like immediately. Like you press a tiny bit before. You still want to let the thing happen. So this is called, like, they'll either call it a jump buffer or attack buffer. Just input buffer is the general sense for any button, because we're going to do this for all buttons, because you should do it. So rather than that, what we're going to do is we're going to go in and make a buffer here. Sorry for my cats running in the background. My dad's cats, I'm just taking care of them. Okay. So a buffer, for the people lacking in knowledge of computer science jargon, a buffer is memory that stores anything, any kind of data. We're just storing data somewhere in memory to reference. And it generally means an array of something. So this is our buffer. Consider this a buffer. This is a list of the buttons we press. So when we press A, or attack, or whatever, I'm just going to call it A, press. What we're going to do, instead of sending the signal straight in here, we're going to put it in the buffer. We're going to go red. A. Then, when we press B, we're going to send it here, B, whatever. And then each frame of the game, which I'm going to represent with this little clock, okay? As often as possible, we want to check whether it's okay to execute, whether you're on the ground, whatever. We want to check whether it's okay to execute what's in the buffer. And we're going to do that action. Check, right? Check. And then now we will attack if it's good. So in the case of jumping, which is a very easy example to understand, this check would be, are you on the ground? Yes, no? Okay. You don't have to be pressing the button for this check to happen or this execution to happen. So this will let the thing happen after you press the button, and you can restrict when this is possible. So all you need to do is keep an array of the inputs that the player does, and then regularly do a check, and if the check is okay, then you start doing the buffer. When you want to actually do the buffer, what we're going to do is the actual process of executing the buffer. We're going to pop this out. We're going to take A and bring it out. And it's going to be removed from the buffer. And then B is going to be the next thing in the buffer. And then the process will repeat. However, for our purposes, we're going to do something else. We're going to beat them up. Because we want to enable things like combos. We're going to keep a record also of the old stuff that we did press already. So this is going to get executed, and it's going to get pushed in here. Old stuff. In my world, I call this the execution buffer and this the input buffer, but that's kind of back. It's not really common terminology, so forgive me if I forget. This is an input buffer. This, I don't really know what they would call this, but they might do things differently. They might keep this all in one place and execute along the line, and just keep the stuff in the input buffer and track the old stuff. That's not how I do it. I keep two buffers and I push stuff from here into there. And the purpose of this, then when that's done, then we get A, and then after B is done, we're going to add another one. Add another one here. And then B will get pushed on. And then B will get removed here once A is done, and you get the idea, right? And then what this is going to enable us to do is check when this execution happens if the last button pressed was something. Maybe we want to do something else. This would let us do a combo. You can go 1, 2, 3, A, and then you'll do jab, long punch, uppercut, right? It'll give you a little more flexibility. And that's how, if you want to do a fighting game, if you want to do motion inputs, like Ryu's Hadouken in Street Fighter, down diagonal, forward, A. So you would track everything that's going on here. Track all that. So this is going. So if the last 3 were this, right? And then you put punch. Then this, you check this, right? And then this becomes Hadouken. Okay. Instead of a punch. Got it? Not so bad, right? Let's try implementing. Let's try a little implementation. Let's look at some implementation. I know I said I was gonna not show you how to do it. It'll be easy to understand if I show you some code. Gotta show you some code at some point. This is Godot. This is GD script. I'm going to keep it very simple, and hopefully I don't know tons about the other I don't know tons about scriptable objects or blueprints or whatever, but you're going to have to get your hands dirty with code to make this work. And if you're making beat 'em ups, you're going to have to do that. You're going to have to use GML. You're going to have to, I don't know about construct. You're going to have to get into some code. There's no other way. I'm sorry. Especially for input. So rather than pseudocode, I'm just going to use GDScript because honestly, I think it's very easy to read. I think that it is practically plain English. Very easy to follow. My opinion. Okay, explain what it does. GDScript has what are called callbacks. These are functions that happen regularly. They are executed by the engine. Input is a callback that runs every time there's any user input, keyboard, joypad, mouse, any kind of thing like that. Physics process runs every frame. There's also this process for Godot people who want to know something. Process. There's also this. This runs as often as possible. This is like an update method that runs every single possible time the program can run. And it's still called frames, but this is fixed frames. This is, if you set your game at 60 FPS, this runs every 60 times a second. Delta will always be fixed. In regular process, delta will vary based on how long it was since the last time processor was called. Okay, hope that clears things up a little. So, what are we doing here? An event could be a lot of things. This is how you get input from the user. The event will tell you whether it is a keyboard or a joypad or whatever else, mouse. Now, all we care about is the fact that we have this event. We have defined a buffer. This means, in Godot, this is the way you define typing. This colon tells it that whatever follows the equal sign, that is, this variable is going to be locked in to that type. This is an array. This is an empty array. So by doing colon, I am ensuring that buffer will always be an array. My buffer variable. This is typing because GDScript is dynamically typed, which means that variables can be of any type at any time. You can reassign. I could have an array and I could change it into a number, and you wouldn't really be able to tell. You'd have to check the type. So that's what's going on here. This is our buffer. Remember, that's this. It's an array. So now we are pushing the event into the array, just like we said here. This push gets pushed. And then during physics process, we're just going to print it out. This stuff is all just for sake of showing. I forgot one line. Need to add this time. So what this does is it goes through our buffer and it prints out specifically if it's a key. The way you tell the keys apart is by the scan code variable in the event. And for joypad, it's the button index. But I'm not going to plug a joypad in, so you just have to trust me on that one. And then we print out the array. So it should show us the index, which is just a number, the scan code, of each key we press. Let's see if it happens. There it goes. Also, you'll notice they happen twice. So I'm pressing like Z, X, C, and those are the numbers associated. It's doing it twice. Why? This could be button down or button up. So we're going to add one more little check. So this function will tell you whether the see. Okay, so the event is pressed. Oh, and. Let me make this more obvious. Very, very clear English. So you can do it anywhere. There we go. Okay, so I'm pressing buttons. We have now kept track of what button is pressed. What do we want to do with that? We want to use them to execute something. So what I'm going to do here is I'm just going to execute one every couple seconds. I'm not going to send it to any fighter yet. I'm just going to keep it simple. We're going to pop one off the stack and say executed 70. Okay, let's see. How are we going to do that? I'm going to make a timer. When we assign a type like this, using a decimal point will cause timer to always be a floating point number, which is decimal in programmer speak. If you did this, it would be an integer, and you could never have a floating point decimal part on the number. So this is an important distinction. Just to let you know why I'm doing this. It is very important. Okay, so then what we're going to do is pushing in the back, we're popping on the front. Okay. So pop means take it off. Push back, pop front means, back to our example here. So this is misleading. The way this is actually happening, it starts empty. The way it works is, as soon as you press a button, it pushes onto the back. When we press B, this is the back of the array. We go here. So this is the back, this is the front. So when we push back, push and pop are opposites. Push means add, pop means remove. You can push back, pop back, that's going to treat it like a stack. It's going to do first in, last out. This is first in, first out. Another computer science jargon term. The first thing that goes in is the first thing that goes out. So in order. Push A, we want A to execute. Push A, then B. A should execute first, then B should execute after. So A is going to get popped off. And then B will be next in the queue. So that's why we're doing pop front. We have the event. And then we're going to call it print call it print executed. This is called a format string. This is borrowed from C, the C language. This is functionally equivalent to doing something like this. So it's the same type of thing. With a format string, it just lets you insert whatever you have after this argument into this format. So S means string. String event is going to get converted into a string, and it's going to show us something else. But this will let us know. Okay, we're executing that. Pop removes the thing. So every 1 second, hopefully it'll say it executed something and it'll remove something from the array. Let's find out if it worked. Oh, I forgot something. Timer is not getting incremented. Timer 0 plus delta. So remember, delta is a small number. In this case, I am at 60 FPS. Every 60 frames, it should be equal to 1. So delta will be, I think, 0.016, I think, is the number. So we're adding, each time this is called, we're adding delta, which is little by little. Delta is 1 divided by whatever frame rate you have to find. So once timer is greater than 1, that means 1 second has passed. We get the thing off the top, we say we're executing it, and then the timer is reset to 0 so that it can start over and loop through that. Doing this instead of using a timer node in a lot of, you can do, generally in engines, you're going to be able to make like a timer or something like that. This is a little more accurate. No, not a little, very, very much. And it's simpler, it's less, nodes have overhead cost. They are objects and they have a lot of data that you might not need. This is a tiny, tiny little section of memory. So this is more efficient. And using physics process is even more efficient because it doesn't run as often as regular process. But you can use regular process to get even more precise if you want. In this case, we're just going to execute every frame because that's fine. That's preferable. You want things to happen every frame. Okay. See that happen? It's a little bit, so I'm pressing a bunch of keys and then every frame, or every second, something is executed. And then we get back to nothing. This should be, yeah. So like I press, so maybe the next thing to do is to only print every time, instead of every frame, we're only going to print it when we add something to the buffer. That's probably better, right? Yep. Oh, and anytime we execute an event, we also So every time we execute, something is popped off the front, see? So I pressed, what did I press? We'll investigate, we'll inspect. So I pressed 83, 83, 60, I pressed 83, then 65, then 68, then 70. 83 gets executed first, then 65, and it goes away, then 68, and that goes away, and we get down to 0. There it is! That's the buffer, that's all it is! Technically, in the real game, you're not going to use this, you're not going to use this, you're not going to use this. Look at how simple it is, right? And the thing that is going to define the way it works for your game logic is this. When do you actually execute the buffer, right? So right now we're just doing it every second. What you probably want to do is check each frame whether your fighter's on the ground, and then you execute the next thing in the buffer if they're on the ground. With a jump, I mean, it depends, right? If it's a jump buffer, then that's what you're going to do. If it's some other kind of input, if it's an attack input, maybe you want it to execute in the air or on the ground. So the first thing you'll do is something more like check position y is less than or is equal to 0, right? Or on ground. There's also, if you're using a kinematic body and you're doing a platformer, you can check if they're on the ground, like literally. But whatever criteria you use to decide whether the player is on the ground depends on what kind of game you have. Noticeably, this has nothing to do with 2D, 3D, right? Nothing. No bearing on 2D, 3D at all. This should be used in both types of games. Difference is here. It completely depends on your game when you want to execute. Are you ready for your homework? Check it out. Nope. Works in 2D, 3D. Doesn't make a difference. Make that work. Do it in one or the other. If you can get it working in one, then try it in the other. Unless you don't care. If you don't care about one or the other, then just skip it. Ready for your homework? Take a look. There you go. Jam in the button. Now I'm not pressing the button anymore. It's going to jump as many times as the button presses. But he's not jumping, you know. That's a buffer. It's in 3D too. Jump, 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 jump. They jump at different speeds. I'll give you some hints. You should be able to make something like this. Something, a little jumpable person, right? There's lots of tutorials on how to make jumpers. Something like this. You're going to have a different buffer. Here's the code, okay? You get to look at it for just 1 second. Shouldn't take long. It should be like 10 lines of code to be able to make a 2D sprite jump. The 3D sprite's a little... Look at that. We've expanded the code that I wrote earlier to execute the jump methods on these characters. That's all you got to do. Do one or the other. If you don't care about 3D, if you don't care about 2D, just do one or the other. Neither one is easier than the other, actually. The only thing that might be harder is like getting the setup. But, and this is just a single sprite, but I mean, like, the actual thing, you give this a jump function, you give this a jump function, this buffer should be able to execute the jump function. Got it? Don't worry about this little labels. If you want to do that, that's extra credit. You get extra points if you can make some kind of little label in the game that shows you what the buffer's doing. Got it? You got it. Got some questions? You need some help? Office hours are subscribing and joining my Discord.